Today we are going over lesson 9-7, which is titled Theoretical and Experimental Probability. We're going to start this section out with an experiment. Before we can start the experiment, however, we're going to calculate the probability of rolling an even number with one number cube. So remember, probability tells us right away that we have number of favorable outcomes over number of possible outcomes. So, how many favorable outcomes are there of rolling an even number? Well, we have numbers 1 through 6 on the number cube, so we have 2, 4, and 6. 2, 4, and 6, which makes 3 possible ways of getting an even number. Total number of possible results are 6. There's 6 pieces, 6 numbers, and 6 faces on a number cube. So now we have 3, 6. However, we can simplify that, dividing both the top and bottom by 3 to get 1/2. So 1 out of every 2 rolls, we should roll an even number. Now we are going to do that experiment. We're going to see how many times we roll an even number. So we're going to roll 12 times. So 12 rolls. We'll record them. So we've got 4. Then we've got a 5 and a 2. Then we've got a 1. Then we've got a 2 and a 5. A 6 and a 6. So we've gotten 8 rolls so far. 5, 2, a 1, and one last roll, we're going to get a 3. So, out of our 12 rolls, 2 landed 1, 3 landed 2, 1 landed 3, 1 landed 4, 3 landed 5, and 2 landed 6. Adding those all up, we got 12. So, how many times was the even number rolled? Got 3, 4, 5, 6. In this case, our experiment has that we landed exactly 6 out of our 12 times on even number, which that actually does equal our theoretical probability. And in this case, the two are equal. However, let's go back to the last slide. Going further down, we're going to calculate the probability of rolling a prime number with one number cube. We'll see if we've got the same number with this one. So, rolling a prime number, again, probability is a number favorable over number possible. And again, there's 6 numbers possible on a number cubes. And our prime numbers are going to be 2, 3, and 5. Those are numbers that our only factors are 1 in itself. So again, we have 3/6 chance, which we already know above is 1/2. So now let's look at our prime numbers. So looking at 2, 3, and 5, out of our total of 12, I've got 3, 1, and 3. So here we have 7 out of our 12 were prime. Well, didn't we just see that shouldn't we have gotten 6 out of 12 based on our probability? Right? Because 6 out of 12 is going to simplify into 1/2. Shouldn't we have gotten 6 out of 12? Well, this is where experimental probability comes in. Why might result have not been the same as the probability we found, right? Because we had 1/2 was our probability, and then experiment, we got 7/12 for the prime number. So why could that happen? Well, the point here is that there's actually 2 different types of probability. Theoretical probability is what should happen based on, well, there was 3 numbers on the cube that were prime, and out of 6 possible ways we could roll it, that means that 3 out of the 6 ways we should get a prime number if it goes according to our odds. Experimental probability, however, tells us that based on an experiment, we might not necessarily get the exact same of what we're looking at a probability. Meaning, if I flip the coin heads and I flipped it again, I wouldn't be destined to get tails, would I? No, I still have a 50% chance to get heads or tail. So the probability is still there. It doesn't, just because I flipped the coin and got heads, doesn't make it less likely that I'll get heads again. So, experimental probability is what actually happens based on the experiment and is also referred to as relative frequency. So if they're asking about the relative frequency that something happened, it's based on the results of an experiment or what just happened. A spinner is spun 30 times and it lands on 4 12 times. So we have 12 favorable outcomes. What is the experimental probability of spinning a 4? Well, we had 12 favorable outcomes out of our total number possible was 30 because we did 30 spins. So the most we could have gotten was 30. So dividing both by 6, we can get 2/5, which gives us 40%. If there's 4 equal spaces, we should have had more of a 25%, but this is what happened. We ended up getting a 40% or 2/5, or we can also write this as 4/10 of the time we spun a 4. Next question is very similar to the experiment we just did. The table shows the results of rolling a number cube 40 times. What is the experimental probability of rolling a 1? So, we're looking at our experimental, meaning our result. Experimental of 1, right? Well, how many times did we roll a 1? Up here I see we rolled a 1 12 times out of a total of 40. So dividing both sides, the top and bottom, by 4, I get that we had 3/10 of the time we rolled a 1. Well, what's a theoretical probability? So the theoretical probability of rolling a 1 tells us that there's one face that is 1, so that's number favorable, right? And how many faces are there on a number cube? Well, there are 6. Again, number possible. So, probability should be 1/6. Doesn't necessarily happen that every experiment is going to be exactly 1/6 of the time where we get a 1. On to the next question. We have, out of 50 people, 20 chose to go to Olive Garden for lunch, 10 chose to go to Chuck E. Cheese for lunch, 5 chose Red Lobster, and 15 chose to go to Perkins. What is the experimental probability that someone's going to go to Chuck E. Cheese? So Chuck E. Cheese. Well, how many was our total possible? Again, total possible is on bottom, but that tells us that we had 50 people. So out of 50 people, the most we could have had gone to Chuck E. Cheese would have been 50. In this case, we actually had 10. So we have 10 as a number favorable. So 10 over 50, both have a 0 in it, so we can by 10, end in a 0, right? Taking out these zeros, we're going to get 1/5, or 20%, or 2/10. Those are all possible answers, because probability can be displayed either way. It didn't tell us it had to be in simplified form of a fraction. Last question we have here is, a spinner with 4 equal sides labeled A, B, C, D was spun 100 times. So they're telling us here that we have a spinner was spun. It's going to look like a circle, dot in the middle. 4 equal sides is going to mean something like this, where each one got about a fourth, A, B, C, D. Then this is what happened. When we spun, we got 5 times of A out of 100. 50 times we landed on B. 25 times we landed on C. And the last 20 times we're on D. What is the theoretical probability of getting a B? Theoretical meaning, in theory, what should have happened? How many times should we be getting B? Well, there are 4 possible choices, right? A, B, C, D. So number possible is 4. The number favorable, there's only one side that says B, so 1/4 or 25% or 25/100 are all acceptable answers for the probability of getting a B. What was the experimental probability? In our experiment, We landed on B 50 times out of 100. 100 possible and 50 favorable. And this actually is able to simplify down to 1/2. Our last question asks us to draw a picture of what the spinner would look like based off of these experimental probability. So up here we already know B should be 1/2. Well, what's C going to look like? 25 over 100. If we simplify that, should be 1/4. 20 over 100 should be 1/5. So the leftover little piece will be A. So down here in the corner, drawing our circle for a spinner, we've got 1/2 should be B. Split what's left into 1/2 to get C. And then we'll have a little slice for A with the rest of it being D. That is what we would get for a picture based off of our results in the experiment. If you need any more examples done, there are some options available for you on the PeerTutors website on Moodle.